Bismillahirrahmanirrahim. Class 12th physics. Today's topic is Columbus law in vector notation. Columbus law in vector notation. Let us take two charges Q1 and Q2. Positive charges Q1 and Q2 separated by distance R. Let us take two charges Q1, Q2 separated by distance R. Let F1, 2 be the force on charge Q1 due to this charge Q2, and F21 be the force on charge Q2 due to this charge Q1. And R12 be the unit vector in the direction of Q1 to Q2, and R21 be the unit vector in the direction of Q2 to Q1. Okay, for like charges, if Q1 into Q2 is greater than 0, for like charges Q1 into Q2 is 0. It is shown in the figure. Then we know that F2 by Coulomb's law, force F21 would be given by 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught Q1 Q2 divided by R square into unit vector R12, our first. And similarly F12 would be given by 1 by 4 pi epsilon naught Q1 Q2 divided by R square into R21. Okay, it is when the charges are like charges. That means the charges are like and the situation Q1 into Q2 is greater than 0. Q1 into Q2 is greater than 0. While F12 is the force on this charge 1 due to charge 2, and F2 is the force on charge Q2 due to this force due to this charge Q1. This F2 is the force on the charge Q2 due to charge Q1, and F1 is the force on charge Q1 due to charge Q2. So since they have opposite directions, then R12 is in the direction of Q1 to Q2, and R21 is in the opposite direction. So we can see they have R12 is in the negative direction of R21. So we can say by applying this condition in the above equations, we can say this F21 would be 1 by 4 pi epsilon naught Q1 Q2 divided by R square. Instead of R21 we can write this minus R12, we can write R21 unit vector. Similarly for this F12 would be 1 by 4 pi epsilon naught Q1 Q2 by R square into R21. So from these we can name this third and fourth. From third and fourth we get F12 is equal to F1 minus F12 is equal to F21. So we can see the magnitude of these forces are equal, but their direction is opposite. They have equal force. The magnitude of the force is equal, which are applying between the two charges, but their direction is opposite. When the direction is opposite, one force is like in this direction, other force, the charges may repel each other. It is condition q if q1 and q2 is greater than 0. That is for like charges. For like charges, forces are equal in magnitude but opposite in direction. Here, the obeys Newton's third law of motion. Every action is equal and opposite reaction. Another, when the charges are these, we say q1 and q2, when the two charges are of opposite forces, f1 f12 with the force or the charge 1 due to this charge q2, and f21 would be the force on this charge due to this charge. Similarly, when settle these charges are separated by distance r, and r12 would be the unit vector between them. But the two at this time the two charges q1 and q2 are opposite charges, and the situation q1 into q2 would be less than 0. At this situation, what would be the force? The force would be F21 would be 1 by 4 pi epsilon naught q1 q2 divided by r square into r12 unit vector, and F12 would be 1 by 4 pi epsilon naught q1 q2 divided by r square into this unit vector. We can take here unit, it was f1 it is f21, it is f21 r21, it is r12 unit vector. But now the force, this r21 is also equal to r12, so we can say these forces are of equal magnitude. They are in equal magnitude. They may attract. This force is coming towards charge q1 and q. The force applied on this charge, it moves towards the q2. That means they may attract each other. If q1 and q2 is less than 0, charges may attract each other. If q1 q2 is greater than 0, charges may repel. It may be asked in the objectives. Now let us take what is the unit of charge. Unit of charge, SI unit of charge. SI unit of charge, we know that the Coulomb's law force is equal to 1 by 4 pi epsilon naught q1 q2 by r square. We can take here also r cap also. That is the unit vector. R cap, it shows the direction. Always this r cap, its value is equal to 1, so we can't we can't put it in the equations. So f is equal to 1 by 4 pi epsilon naught q1 q2. Say if q1 is equal to q2, say they are equal to q, and f is equal to 9 into 10 to the power 9 newtons, and 9 into 10 to the power 9 newtons, then we can say this is equal to 9 into 10 to the power 9 newtons instead of this 1 by 4 pi epsilon naught. We may use here also 9 into 10 to the power 9 newtons divided into q divided by if the distance between the two charges is equal to 1 meter, so we can take 1 cos square, then it may be equal to this, and this may cancel. It is equal to 1 into 9 q divided by 1 cos square. That is 1 is 1. Q is equal to q. It may be here these are equal. Q1 it is equal, q1 is equal to q2 is equal to q. So instead of q1 we may write q, instead of q2 we may write q. It is also here q. It is also here q. So it becomes q square. It becomes q q square bata 1. So r q square is equal to 1. So r q is equal to plus minus 1. So we can see charge q, it has a unit of 1 coulomb. 1 coulomb plus minus 1 coulomb plus minus 1 coulomb. Is 1 coulomb of charge के 1 coulomb of charge is equal to 1 coulomb of charge is equal to 6.24 into 10 raised to power 18 electrons. It is asked in the objective sometimes. 1 coulomb of electron. That means many electrons. We can't count them in our whole life. If we count these electrons, 100 electrons per second, 100 electrons per second, and it may take millions of electrons to count the electrons in one coulomb of a charge. Thanks.